today I'm going to go through what you might have missed on Thursday, which is an explanation of two-column proofs. What we're going to start out with is we're going to start out with the algebraic equation 3x plus 1 divided by 2 equals 7, and that's going to be our given. So what I did here is I wrote down step by step how I would solve this equation. First I started out by multiplying by 2 to get that 3x plus 1 equals 14. And I just say a little note for myself. This part is not necessary when you're going through the proof, but it's a good idea to keep track of where you or how you came to that conclusion. Our next statement, I subtracted 1 from both sides, making a note on the side. I subtracted to get 3x is equal to 13. And finally, I divided both sides of my equation by 3 to get my final answer of x equals 13/3. So what we actually just created is half of the two-column proof. So a two-column proof, there's going to be a few fundamental parts. There's going to be our given, which is always going to be a statement or a list of statements that we're going to have to work with. There are ingredients for our recipe. And then our proof, they would actually give us the fact that we're trying to prove that x is equal to 13/3. So the difference in constructing a two-column proof versus what you might have seen in your previous algebra classes is that you're given the final answer. And what you need to do is show your reasoning to get to that point. So from here, in my steps that I numbered, what I actually just created was the statements column of my proof. So then what is left for me to do is to provide my reasoning in the other column. So my reasoning, I would go through and have identical numbers to what I have on my side. So 1, 2, 3, 4. And at this point, I'm going to pause so that you can grab out either your Properties of Equality worksheet, which is handed out, or download it off of Prism. It's under the Reasoning and Proof section, and you just download Properties of Equal. I believe it's abbreviated, so go ahead and grab that. Okay, back from the pause. Now we're going to provide reasoning based on those properties of equality as to how I came to my conclusion. So when you're starting a two-column proof, you're always going to start out with your given, because what we're doing on our left-hand side is we're actually listing all the ingredients we have to get to our final product, which is going to be whatever our proof is. So in order to use our given in our recipe, we have to list it. In my second step, the way I got to the equation 3x plus 1 is equal to 14 is I utilized the multiplication property. You can abbreviate and just put multiprop, but I happen to write out multiplication so that you have it for future reference. On our third step, what we utilized is subtraction, because we subtracted our 1 from each side. And then finally, to get our proof, which is always going to be our last statement, we always want our last statement to be verbatim as what we are asked to prove. So because I got to my last statement, I utilized division. So as a review, the basic ingredients of a two-column proof are we're going to start out listing our given. We're going to write our reasoning. So this is, I wouldn't say reasoning. I would say more like a chain link. You're going to create each link to get to your final product. So these are our links. And then finally, our final product should be what we want to prove. So what we did in class is we did a number of examples of algebraic proofs, and then we introduced ourselves to segment proofs in geometry. So if we want to look at a segment proof, normally the way the given and the proof is written out in a segment proof is we're going to be given a diagram, and then we'll be given certain constraints about that diagram. So I'm going to start out with a line segment A, with a point B in between. I'll be given that AB is congruent to BC, and I'll be asked to prove that AC is equal to 2 times BC. Now a little note, as you can see I just messed up there. A note to keep track of is that when you're using the congruent symbol as opposed to equal, you have to put the bars over your segments because it's actually talking about the shape of the segments. Whereas here, I didn't use my bars because I'm talking about the length. So as per usual, we're going to start out with my given, which is just that AB is congruent to BC, which is just given. And here I'm going to give you a moment to pull up your geometry toolbox. We added to that on Thursday, so if you were missing notes, either get that from one of your peers or get it from the website. If you look at the bottom of the Reasoning and Proof section, it's actually lists Geometry Toolbox. It has everything we've added so far. So I'll give you a pause to get that out. Okay, back from the pause. So the last thing we added to our postulates column on our Geometry Toolbox is the segment addition postulate, or SAP. And all SAP is saying is that the whole is equal to the sum of the parts. So if I had a line segment X, make this point a little closer, Y and Z, then I know that the entire segment XZ is equal to the sum of its smaller parts, which are XY plus YZ. Going back to our two-column proof, I want to apply the same concept to our line segment AC. So utilizing SAP, or segment addition postulate, I can write that AC is equal to AB plus BC. And our reasoning there would just be that. Our third part of our statement is that we're able to see from our given that AB is equal to BC. So here, what I can do, I can actually substitute in my BC for my AB in my original SAP equation. So I'd have that AC equal to BC plus BC. If you recall on your Properties of Equality worksheet or download, depending on how you did it, I would have just utilized substitution. Keeping in mind that substitution is just when you can interchange values or, well, values. You can interchange values to achieve a different equation. Different but equivalent. And then what I can do is I can combine my like terms to get that AC equal to 2 times BC, which is just addition property. So what I want to go through to check to see if I finished my proof correctly, so I'm going to check to make sure I have my givens listed, check to make sure my steps here are spread out as they can be, given, meaning that each reasoning is listed. And then finally, I want to check to make sure my last step lists exactly what I'm trying to prove. Okay, so keep track of your geometry toolbox and your Properties of Equality worksheet. You're going to be using those throughout the semester just make sure that you have them for when we add on. Hopefully that enlightened you a little bit as to what a two-column proof is. And feel free to pop in and ask questions either during resource, homeroom, or also on tutoring, which is after school, Tuesdays and Thursdays until 3. Thanks, guys.